Welcome back. In today's session, we are diving into one of the most powerful features of Tableau, that is calculations. Calculations allow us to create new data from our existing data, thereby helping us derive new insights from the data. Calculations can range from simple arithmetic to complex calculations and logical operations. In the previous video, we learned how to create calculated fields. In this video, we will cover everything from basic calculations to advanced level of detail expressions and table calculations, the three main types of calculations in Tableau. These computations are different from one another in terms of where the data is processed and the granularity of the data. Let us first explore basic expressions. Basic calculations are the simplest form of calculations in Tableau. They are typically used for basic arithmetic operations, string manipulations, or date calculations. In basic calculations, data is processed at the data source level, meaning they affect the raw data before it is visualized. They can either be row level calculations or aggregate calculations. Row level calculations operate on each individual row of data in the data source. Some of the examples include arithmetic operations, in which one field is subtracted from another, string manipulations to extract few characters from a string, date calculations, this extracts the year from the order date, or conditional statements. On the other hand, aggregate calculations operate on groups of data, summarizing multiple rows into a single value. These calculations involve aggregate functions such as sum, average, minimum, maximum, etc. Let's see how to do basic calculations in Tableau. We will use sample superstore data for calculation. This data set contains information on sales and profit, which can be used to compute the cost for every item that has been sold. We will create a calculated field for that. The cost can be computed as a difference of sales and profit. Once the field is ready, we will drop it in the view area and view the underlying data. The underlying data shows that cost is being computed for every record in the data set. This is an example of row-wise calculation. Note that when the field has been added to the view, Tableau summarizes it to show the total cost for the entire data set. We can change the type of aggregation if we want. We can change it from sum to show the average. Now we see the average cost for the entire data set. Note that the granularity at which the aggregation is performed is determined by the view. If we add region, we now see average cost for each region. Aggregation can also be performed using calculated fields. Let us create a calculated field to compute average sales. We'll drop this field in the view. We see that average sales for each region is being computed. If we add state in the view, we see that now the aggregation is performed at a state level, and we see average sales for each state. In this visualization, we are computing the aggregates where level of aggregation is determined by the visualization. What if we want to see average customer sales in each state? It is not possible to do that in this view, as the granularity of our computation would be different from that of the view, since we do not have customer level information in this view. This brings us to the concept of level of detail expressions. Level of detail expressions are used when you need to calculate a value at a level of detail that is different from the visualization level of detail, which is determined by the dimensions in the view. There are three main types of LOD expressions: fixed, include, and exclude, and each serves a unique purpose in our analysis. Let us begin with include. It calculates a value at a more granular level of detail than the view. In this view, we have a level of detail up to region and state. If we want to show average sales per customer for each state without explicitly including customer as a dimension, then we can do so by including customer level details in the calculated field. Let us see how. We create a calculated field called sales per customer, in which we will compute customer level sales by including customer ID. Since we already have level of details for region and state, there is no need to include them in the view. Once the field is ready, we can drop it in the view to visualize. We can change the aggregation from sum to average. And now we see average sales per customer within a state for a given region. This was an example of include, which is used when we have to compute values at a finer granularity than what we have in the view. But what if we want to compute values at a lesser granularity than the view? In such scenarios, we use exclude, which is used to remove dimensions from a visualization for calculations. For example, in this view, we have data up to the level of state, and if we want to compute region-wise sales without removing state from the view, we will have to use exclude in our calculated field. Let's do this. We create a calculated field and call it exclude state. Since we want to compute total sales at region level, we will have to exclude state dimension in our calculated field and take the sum of sales. When we drop this field in the view, we see the same sales total for each state, and this is because this total corresponds to the total regional sales. One use case where exclude would be needed is in computing percentage of total sales for each state. To do that, we need to divide the sales of each state by the total sales across all regions and states. Since we already have state-wise sales in our view, all we need is the overall sales across all the states and regions, which can be easily computed by taking the sum of sales after excluding region and state dimensions in our calculated field. Let us create a calculated field called percentage of total sales, which will be the ratio of sum of sales at state level and total sales after excluding state and region. We will add this field to our view and change the format to percentage. What we see here is the percentage contribution of each state towards the overall sales. So far in LOD expressions, we covered include to calculate at a higher granularity and exclude to calculate at a lower granularity than the view. What if our calculations are at the level which is independent of the view? For example, in this visualization, we see customer-wise sales. Now, if we want to highlight how much of these sales came from profitable versus unprofitable orders, we need to calculate order-wise profit, which is nowhere related to the existing view. For such scenarios, we need fixed type of LOD expressions. Let us create a calculated field to categorize whether our order is profitable or not. We can do that by going to Analyze and create calculated field. However, there is a quicker way to accomplish this. Since we need to compute order-wise profit, I will select order ID and profit together, right-click and choose LOD calculation. We'll name the field as order profitability. By default, Tableau has added fixed type of LOD expressions to compute order-wise profit. We will modify it to categorize our orders into profitable or not profitable. Adding this field to the view shows us that by and large, orders for most of our customers are profitable. This customer although stands out. Despite contributing maximum towards the sales, most of the orders are unprofitable. This brings us to the end of LOD expressions. Finally, let us explore table calculations. These are calculations that are performed on the results of an already created view. They are computed after the data is aggregated and rendered in visualization. You can use table calculations for a variety of purposes, including transforming the values to rankings, showing running totals, percentage of totals, moving averages, etc. Let's see an example. In this visualization, we are looking at the segment-wise sales in each region in comparison to the average sales of that region. The reference line in each pane corresponds to the average sales within that region. If the sales of any segment is below the reference line or below the average sales of that region, it is highlighted blue, otherwise orange. Such types of calculations can be easily performed using table calculations. In future videos, we will look at how to create such visualizations in Tableau. This is all that we have for today. To recap, we looked at basic expressions, level of detail expressions, and table calculations in Tableau. Thanks for watching.